Okay, so I want to tell you how to break a wall of quantum computing. So what is our problem? Just imagine that you have a quantum computer of sorts and how the information might be stored in it. So one particular realization is just the atom cloud. Just imagine that you have a bunch of atoms somewhere, okay? So, and how the information is stored in it. Let's zoom in a little, and each atom has a tiny magnet in it, and just by the direction of the magnet, we can store the information. The magnet is up, the bit is 1, and so on, okay? And let's represent it just by an arrow this direction. Okay, so we have an atom cloud with magnets, and there is magnetic field permeating this atom cloud. The magnetic field is used for many various things, to rotate, to store information, to retrieve it. Okay, and let's see how the magnetic field acts on this tiny magnet. And it turns out that it just rotates the direction, okay, with the speed proportional to the magnetic field strength. Okay, so it looks like this with the arrow notation. And now there is a problem. The magnetic field is not constant, and if we see that at the beginning all the arrows pointed in the same direction, they start to dephase because there are different magnetic fields in each of the points. Okay, so that's the problem I'm considering, and how to overcome this. Well, we can because we can't really destroy these fluctuations of the magnetic field. They are always there. But we can control the interactions of the atoms, okay? So if each of the atoms has a tiny magnet, they create kind of, well, not really, but kind of, they create their own magnetic field. So they start to interact with each other, okay? So they kind of rotate around each other, and we can use this effect. We can turn it on by, I don't know, increasing the density or whatever. There are many various scenarios, and if at the beginning, without the interactions, they start to dephase, just by turning on the interactions, they start to kind of rotate around the average, in addition to the rotation around the magnetic field. And you can see that they all pointed in different directions here, and now they are more concentrated and more information is stored. Okay, so that's it. Thank you.